All right, let's get right into it. Today, we're talking about something huge, a real breakthrough that is completely resetting the clock on AI video generation. We're looking at a new way to create high-quality video at a speed that honestly felt like total science fiction just a few months back. So let's dive in. So what's the big deal? It all comes down to this number: 5 seconds. Imagine generating a complete, high-quality video in the time it takes to, well, snap your fingers. That's the magic number we're going to unpack today, and it represents a massive, massive leap forward. And look, this isn't just some theory. The team behind a new model called FastWan put this claim right out there. A 5-second, 480p video generated in just 5 seconds on a serious GPU. But get this, what's maybe even crazier is that this is now something you can do at home. That same task takes just 21 seconds on a regular consumer card, like an RTX 4090. So you gotta ask, right? How on earth is that even possible? How did they manage to speed things up so dramatically? To really get it, we first have to understand the massive wall they had to break through. Okay, so to really appreciate the solution, you first have to understand the problem. For years, the biggest thing holding back AI video has had a name: the attention bottleneck. This is the fundamental reason why making good video with AI has been so mind-bogglingly slow and expensive. To give you a sense of scale, think about a single 5-second video. Once an AI breaks it down into pieces it can actually understand, you're looking at over 100,000 individual chunks of data, or tokens. Each one is a tiny piece of the visual, a fragment of time the AI has to make sense of. So, what is this attention bottleneck? Well, in a typical AI model, every single one of those 100,000 tokens has to talk to every other token just to make sure the video stays consistent. The number of calculations just explodes. It grows quadratically. And this one step was eating up more than 85% of the total generation time. Just insane. Here's a good way to think about it. It's like the crowded room problem. The old way, full attention, is like being in a huge room where every single person has to have a one-on-one chat with everyone else before anything can happen. It's a complete mess, right? The dream has always been sparse attention. What if you could just magically know which conversations matter and ignore all the rest? That would be efficient. And that leads us to this impossible chicken and egg problem that was at the core of this research. How do you find the important parts, those key conversations in our crowded room, without paying that ridiculous price of listening to every single conversation first? Solving that paradox, that was the key.
So how'd they crack it? Well, the researchers came up with something new, a technology they call Video Sparse Attention, or VSA for short. This is the first big piece of the puzzle that makes FastWan, well, fast. So instead of trying to process 100,000 individual data points all at once, VSA's first brilliant move is to group them together. It chops the video up into these manageable little 3D cubes. Each cube is a little chunk of both space and time, which is a much smarter way to organize the data from the get-go. And how does VSA use these cubes? It's a really slick two-step dance. First, you have the core stage. This is a super lightweight process that just quickly scans the cubes, not the individual pixels, to get a rough idea of which parts of the video are most important. Then comes the fine stage, where the model does all the heavy lifting, the really expensive attention stuff, but only inside those few important cubes it just identified. Finally, it intelligently stitches the information from both stages together. It's like a super smart triage system for computation. And the result of this is incredible. The AI learns to pay attention in a way that's genuinely intelligent. It adapts. For some frames, it might zoom in and focus on a tiny local area. For others, it pulls back and looks at the whole scene to understand the bigger picture. It's not just faster, it's smarter. But VSA is only half the secret sauce. To get all the way to that unbelievable 5-second generation time, the team needed one more key ingredient, a clever training technique they call sparse distillation. So what is this sparse distillation? It's a brilliant trick. You take a massive, powerful teacher model that uses the old, slow method to make incredible videos. Then you create a smaller, nimbler student model that uses the new, fast VSA method. And the student's only job?
learned to make videos that look just as good as the teachers. It basically inherits all the wisdom and quality, but with none of the slow computational baggage. And you can literally see this happen during the training. At the very beginning, the student model's videos are just a noisy, garbled mess. But as it keeps learning from the teacher, it gets better and better, and those ugly artifacts just melt away. It's figuring out how to be both fast and good all at the same time. Okay, so it's way faster. But is it any good? I mean, that's the usual trade-off, right? Well, this is where it gets really interesting. They put it to the test with real people, a blind comparison against another method. The result? Over 55% of the time, people actually preferred the video from the new super fast VSA model. So quality didn't just stay the same, it actually got better. And if you want to see just how wild this is, look at the raw numbers for the single most intensive step of the whole process. An already optimized method takes over 95 seconds. With VSA and their other tweaks, less than 1 second. That is almost a 100 times speed up. The numbers really do speak for themselves. So let's step back. What does all this actually mean for the future of making video? This isn't just a small step up, it's a total paradigm shift. We're going from a world where generating AI video could take minutes or even hours to one where it happens in seconds. A new era is definitely beginning. The implications here are just massive. First, accessibility. Suddenly, high-quality video generation is a real possibility on the computer you might already have. For creativity, it means artists and filmmakers can try out ideas almost instantly, instead of waiting forever for a render. This also blows the doors wide open for new things, like interactive media or content that's generated in near real time. And for the researchers building the next big thing, this dramatically cuts down the time and money it takes to experiment. So here's the bottom line. For years, AI image generation has been almost instant, while video has been stuck in the slow lane. Now, that gap has been slammed shut, and that leaves us with one final fascinating question to think about. Now that making a video can be just as fast as making an image, what totally new kinds of creativity and communication are we about to unlock? Thanks for watching.